Hey guys, this is 4.2. We're going to be looking at modeling with linear functions. So basically some word problems that we can apply linear functions to, and then use those linear functions to evaluate different information about the situation. All right, so number one, working as an insurance salesperson, Lily earns a base salary plus commission on each new policy. So she earns just a certain amount of money each week or month or whatever. So base salary, and then on top of that, she gets commission based on her sales of policies. Therefore, her weekly income, I, depends on the number of new policies that she sells during the week. Last week, she sold 3 new policies and earned $760 for the week. The week before that, she sold 5 new policies and earned $920 for the week. A, find Lily's rate of commission per policy. So we're trying to figure out how much is she making on each policy that she sells in a week. So what we want to do is, first of all, the rate is commission that they're looking for. The rate they're looking for is commission per policy, which per means divide. So what that tells me is, if you think about slope, which we just talked about, slope is y over x, right? The change in y over the change in x. So that means that we want the money to be our y values. The commission is going to be your y values. And then the number of policies is going to be your x values. So y equals money, and x equals n, the number of policies that she sells. All right, so now that we know we're doing commission over policy, so our y values are our commission and our x values are our policies, we can say that they gave us actually 2 points. So the information they gave us is that 3 new policies she earns $760 for the week. So you could think of that as a point, 3. See, I'm putting 3, the number of policies, as my x value, and 760 would be the y value. And then you have 5 policies earning $920. So that would be the point there. All right, so now we can use those 2 points to find the rate of commission per policy, because we know rate is just slope. So we're going to plug those 2 points into the slope formula. So we're going to do y2 minus y1. So 920 minus 760 over 5 minus 3. Okay, so 920 minus 760. So you get 160 over 2, which comes out to 80. So she's going to get $80 per policy. $80 per policy is the rate there. Okay, so there we've got that. And that is your slope for this one. Part B, find an equation for I of n. So remember, they said I is your income. So we're trying to find the income in terms of the number of new policies. So I of n is going to be equal to, okay, let's just use y equals mx plus b, right? We've got I of n equals, and we have our slope, 80 times n. So for each new policy, you're going to get $80 more. If I plug in 2, then I've got 80 times 2 is $160 for that week. Plus her base salary. Which we don't know what that is yet, so we need to solve for it. Well, how can I solve for it if I have all of these variables? Well, we do have some points. we have both of these points up here, so we could plug in either of those points in for I of n and n, right? I could do 760, that's the income, when she has 3 new policies. So I just plugged in that point, and now I can solve for B to figure out the base salary. So 760 minus 8 times 80 times 3, sorry. 760 minus 80 times 3. So I get 520 for B. Okay, so now my formula, putting all of that together, is going to be I of n. My function is going to be I of n equals 80n plus 520. All right, and now let's use that on part C to answer this question. Calculate Lily's income if she sells 8 policies in 1 week. Now that's an ambitious goal, but maybe she gets lucky at some point based on these two numbers that we have, 3 and 5. 8 would be a really good week for her. So let's just see how much she would make if she did sell 8 policies in 1 week. So that would be the income when n equals 8. So we've got 80 times 8 plus 520. 80 times 8 plus 520. Her base salary is 1,160. So if she sold 8 policies in a given week, she would make $1,160 that week. That is very good. All right, let's look at number 2. In 1980, the average monthly rate for basic cable TV in the United States was $7.69. Phew, I wish. In 2008, the average monthly rate was $46.13. Okay, so we've got, hopefully you can see that we've got 2 points there. I could do this point and this point. We don't know which one should be X or Y yet, but we'll see in the question. It says assume a linear relationship and find the average rate of change in the monthly rate per year. So the money, the monthly rate, that's the cost. So your monthly rate per year. So that means my Y's are on top. So my monthly rate is my Y. So the money is Y. And the year is X. All right, so that means my 2 points are 1980, or you could just do 80. Actually, yeah, you could, but we're going to do 1980, and then $7.69. And then in 2008, $46.13. Okay, so those are the 2 points that you have, the 2 pieces of information. All right, so it says to find the average rate of change. So we're finding the slope, or just how much, you're finding out how much the cost is increasing per year. How much is the cost increasing per year? So we're going to do 46.13 minus, just doing y2 minus y1, my slope formula, rate of change, okay, let's see what that comes out to. 46.13 minus 7.69. And then I've got 2008 minus 1980. And I'm dividing those numbers. So I'm going to scroll up, grab that, divide by 28. I'm going to hit math frac just to see if I can get a more exact number here. And so that fraction would be 961 over 700. Okay, so it's going to change by $961 every 700 years. So that's a little irrelevant. But if you look at the decimal right here, it was actually only increasing by about $1.37 per year. It's not that much when you think about it that way. All right, so write a linear function to represent this scenario. So we want to write a function. Let's do, since the y value here is our monthly rate, we could say R for rate. And then the x value is your year. So maybe we'll use, yeah, we can use y. So the rate for a given year, we're going to have our slope 961 over 700. Times y plus, we don't know. So I'm going to put b there. So y equals mx plus b. We don't know our b at this moment. So let's solve for b. So we're going to plug in a point just like we did earlier. Let's plug in this point here. So the rate was $7.69. And then I'm going to plug in 1980 for the year. And I know this is like not applicable, the b value here, because b would represent the y, b represents the y-intercept, and so that is when the year was 0. We're trying to figure out the cost of cable when the year was 0, and that doesn't apply because there was no cable. There was no cable back then. Okay, so let's solve for that. I can do that 961 times 1980. And then I can do 769 minus that number. So b comes out to negative 2,710.567. Okay, so now we can write our formula with that information. So R, your function, sorry, I keep saying formula. Your function is going to be the rate in terms of y is 961 over 700 times y minus, because I got a negative number there, minus 2,710.567. So I just rounded that to 3 decimal places to be as accurate as possible for our function. I mean, that's not as accurate as possible, but it wouldn't have let me do a fraction here if I hit math frac. It stays a decimal, so we're just going to round it to 3 decimal places and call it good. All right, C, use the function to approximate the year that basic cable will reach $155 per month. So we're trying to approximate the year when the rate is 155, so we'll plug in 155 for the rate and solve for y. Okay, so first I would add that 2,710.567 to the other side. So that's 155 plus 2,710.567 0.567. Okay, so I got 2865.567. Okay, and now I need to, so for getting rid of the 961 over 700, you can either multiply by 700 and then divide by 961, or to get rid of a fraction, you can always just multiply by the reciprocal, right? Dividing by a fraction is the same as multiplying by that reciprocal, so I'm going to multiply by 700 over 961 on both sides. And so that is going to cancel that fraction out. Okay, so multiply that number that we got earlier by 700 divided by 961. So we got 2087.301. Okay, the 0.301 tells me that it's going to actually happen in the next year after 2087. Well, I guess it depends on when they're starting. I guess actually that could be just a 0.3 into the year 2087. That's what that would be. So it's going to happen in the year 2087 based on that prediction. That's actually probably not accurate because I'm pretty sure it's already there, right? So based on this formula, based on this information that we were given, if it followed a linear trend, so it increased at a constant rate, then basic cable TV would be $155 in the year 2087. All right. And that's it for this first video, part 1. We'll finish this tomorrow.